become beautiful till it all burns out. We're like falling stars, miracles dancing on the ground. And we're right with you to feel it strike deep dive. We're right with you, yeah. And we're right with you to feel it strike deep dive. Suffering grows, yeah. Just say that life is beautiful. Would you let me in? No, yeah. Just say that life is beautiful. Let me in? No, yeah.
Welcome, everyone. Tonight is a special occasion. I have the most amazing people here. We have Jason Verbelli, we have Britne, we got Andreas Xirtus, and we're going to be talking about a lot of Searl tech, diamonds and Searls.
And we have two people that are in the fields of like nanotechs, like different parts of nano, like nano bubbles, and then Andreas did like nano stuff. I don't even know. So that'd be kind of cool to ask questions about really small things that matter a lot, a really great deal. So
diamonds are Searl's best friend. Is that the pun?
Yes.
So Jason, they've heard of me. What's your deal? Tell us a bit about yourself.
Yes. So I originally from the San Francisco Bay Area, and I was investigating alternative energy because I wanted a better way of life like everybody else, and sick of paying bills and hearing about these outlandish claims of these eccentric inventors who say they can power homes, they can power cars, and clean the earth and everything. So, okay, this is either some of the biggest hoaxes of man, or it's the most important information ever. So it's kind of like no in between. So in trying to invalidate these things and catch them, with lies, I ended up validating certain people while separating the wheat from the chaff. And one of those people who I have end up validating is a man named Professor John Searl. And he was a British inventor who, as a teenager, was hired by British Rewind Electric Repairs Limited, was the largest industrial electric plant that ran all of London. They hired him because he was a savant and a prodigy. He knew all about electricity and was having these wild dreams about being able to power things, and was making these outlandish claims to his coworkers. They told him, shut up, get out, or build it. So he said, I love my job. I can't stop talking about it. I'm going to build it. So he went, used the infrastructure, all of the factory workers, industrial equipment, and all of the resources available to him that he had access to for free. And he used that to his availability to build this device, which he ended up powering this home with. And it had a bunch of other exotic effects. And so what I did is I moved from the San Francisco Bay Area to San Diego here to dedicate myself to this endeavor to rebuild this man's technology and validate his claims in a professional environment. And if we are successful, it will turn Elon Musk into a partner or a customer.
I was going to say too, he was really young, like 13, right? And they took his technology, or what happened there when he was in, when he was working?
14.
14?
He first started, first he was working for,
it's crazy.
He had many jobs. He was orphaned, beaten until he was mainly deaf. He could only hear partially out of one ear. And the people where he was growing up just mistreated him horribly and said, oh, he's deaf, he can't hear us anyway, so might as well not bother with him. So horrible. So he was left to his own devices just to think for himself, and he came to these different conclusions based upon his reoccurring dreams about energy in a random state all around us, and it can be converted into a ordered wave, and when you do so, it translates that energy into usable electric current. And he did that by translating his dreams, which were about hopscotch squares, and translated that into a volumes of books that he wrote called The Law of Squares, which is like Sudoku on steroids. And he used that like a calculator to determine the quantities of materials and in their order to make this device.
I'm really interested in that because my grandfather was obsessed with Sudoku and with Keno, and he worked for Lockheed. So I wonder also about that in terms of material science, because you can imagine how you could make a graph table with reoccurring patterns that way. Do you know much about that, or what the deal was with that?
In what regard?
And how he was using the number table, or do you know anything about that?
Yeah, it's one of the most complex concepts that I've ever encountered in life. No, I can't explain it the way he thought. No, I can't. I don't want to pretend that I can. But I have I have articles written down which can give you insight onto how he saw it, and you'll just scratch your head as well.
Epic.
But he said he used it like a calculator. Not only that, but he would use it to play games with doctors. He said you can use this like Nostradamus, that you could enter different variables into the squares and you can calculate it for a given outcome. So he would play games with doctors by guessing the birth dates of women's babies and if they would be twins or not, male or female babies. And he would be accurate 100% of the time, he said.
Jason, my favorite part, of course, with John Searl is that the dream he had and how he interpreted, because a lot of the times we have visions or dreams and we can kind of not know how to interpret it. Can you speak of what he dreamed, like what his dream was that is, going up the ladder?
Yes. So one of the dreams was reoccurring. He had these dreams from age 6 to 12, twice a year for 6 years. And one of the dreams was he was playing hopscotch and he's throwing this rock on square 3. He jumps to it and this steamroller comes towards him and he's about to get crushed, but it splits into segments. And that's pretty much the dream. And he translated that into all this stuff. The second dream, he was climbing this ladder up to a loft. He opens this attic door and he gets up into the attic and he sees this ring of hay around the attic door with spokes made of hay. Everything starts to catch on fire, but he said something in his dream tells him it's okay. As long as you're in the center of that ring, you're going to be all right. So he took that to mean that if you build this device large enough in the center of this ring, that even though these electron emissions and all of this energy is discharging around it, as long as you're in the center, you will be protected from it, and it will be converted into a coherent state.
When he was doing that, when he was experimenting with it, and he used it, and it shot through the ceiling and turned on every radio in town, even if the radio was off.
Yeah. So now you're getting to more controversial claims. While he was working at the largest industrial electric plant, he had these factory workers, through trial and error, he wrote down on shop notes and scrap paper, here, start making this for me. And over the course of months, they made these parts for him. He modified their 12-foot magnetizers with mercury rectifier tubes and access to megawatts of power. So he magnetized these materials, had these copper rings, nylon 66 rings, magnet rings, and neodymium pucks. The only thing he had to pay for was the neodymium powder that he got from China at 65 pence per kilo, old British money. He got the neodymium, he pressed it, not NdFeB magnets, although John Searl was the first to experiment with that long before 1982 when they invented neodymium-based magnets. But he used neodymium as the core, and then the nylon 66 dielectric, and then a ring of a magnet, and then copper, concentric rings, and stacked those. And he assembled them at the house. And when he tested those, he just wanted to power his lights or power his shop, but it worked better than expected. So when he plugged in a light, the unit spun faster. when he plugged in an iron, he said it started spinning even faster. And then he plugged in a cooker, like a little oven or little tiny cooker, and he said this thing started spinning so fast, and it developed its own gravitational field, he said, and lifted off of his table and stuck to the ceiling, like trying to get through his ceiling. Nobody taught him this wasn't supposed to happen, so he grabbed onto this thing trying to get it down. His landlady was there. His hands, he said, electrostatically stuck to the device. He couldn't let go of it, and his landlady was like beating it with a broomstick, and then tried pouring it came back down on his workbench. His landlady poured warm water on his hands because his hands were like frozen, because it was stealing the energy from the electrons out of his hand, because everything is made up of incoherent energy. But when you organize it, heat can't really exist in the same form because everything is coherent. So it was stealing the energy from his hands, and he was just stuck to it. So he said, this thing wants to lift off my table. Every time he tried to power something with it, it would try to fly away. So he bolted down a pin into his concrete floor and had a 60-ton cable attached to this device, and said, okay, if this thing wants to go up, then I'm going to hold it down. But what happens if you try to hold a basketball underwater, or like a ball? It tries to fight with you with the equal amount of force that you put it back, equal to the buoyancy of the, okay? So similar sense, but in an electric, magnetic, and gravitational sense, John Searl said, so that when he tried to power this thing, it absorbed electrons so much, it cooled down, because the energy has to come from somewhere. It absorbs it from around it. Like Nikola Tesla said, all the energy is around us from the wheelwork of nature. That's what this device does, is it harnesses that incoherent, randomized energy we take for granted all around us as temperature. It organizes it, steals some of it from different wavelengths, which then drops the temperature because there's less around now, and then converts that to an electric current. But as it does so, if you convert too much too quickly, it will develop gravitational anomalies, he said. That's why it lifted off of the table. So he had this 60-ton cable trying to hold this thing down. He said he powered it up, trying to power some things with it, and it snapped the cable, not at the point at the middle of the cable, like it just, the wire like disintegrated, or just force field or whatever to snap the cable. And then it shot through his roof with over 60 tons of force, blasted through his ceiling, a hole in the ceiling. John Searle said this thing was glowing over his house, silent, cold. Flocks of birds fell to the ground dead. He said people's tiles of their roofs were rippling. And then everybody's radio sets in the town came on full blast, whether they were plugged in or not. So I've heard, Hollywood fiction, like Close Encounters of the Third Kind and stuff, when UFOs are by, everything electrically goes haywire. Same principle. So this guy, this thing flew away, never to be seen again, he said. He lost it. So he built another one.
Black Knight satellite.
And he
What
built
if it
another
got
one.
like hijacked or something as it was up there, and they're like, what is that? Something.
So this thing just never to be. So you can only speculate where it might have gone. Maybe it's don't know, but it's
but how? So wait. Went up,
Yeah.
damaged roofs. He saw it glowing, and then it took off.
Saw it glowing,
and then it was like,
and then just took off in a blink of an eye, like a UFO.
Was it green?
No, it said it was like white.
So you've like magnetics, and have you ever played with like those train toys, and you put the magnets against
The
each other?
maglev train. Yeah.
They go there. Well, even just playing with the push away, because ions, it's an ionic breeze, right? So this is forcing the ionic breeze, which is also creating cold because it's pushing all the heat away at the same time. So you can have a solid state craft that can just propel in any one or any particular direction if it has several valence level. If you have different materials that have been charged differently, you should be able to have any material, like you just completely solid state, and you direct it with radio.
because this is not ion wind. This is
Okay.
developing emissions of gravity itself. Because there's an entirely different. I don't subscribe to relativity and space-time curvature. I subscribe to classical physics and a man named Dr. Edward Dowdy, who says that gravity propagates like light and is emissions like gravitons, but it's not particles, it's emissions like spherical emissions that propagate like Huygens principle at the velocity of c, and gravity can propagate like light. So anything that light can do, gravity can do. There's probably gravitational reflections, gravitational echoes, and gravitational shadows.
So is gravity a wave, or how does this work?
No. The wave people talk about is in regards to the absorption and re-emission of electrons at their level itself. So there are no ripples literally traveling between planets or atoms. You have a constant energy that comes in, and the electrons absorb that, but they can only absorb so much before they have to re-emit again, and then they do so in a wave-like manner, but not that there are ripples propagating. So you have the pulsation and the absorption and re-emission of electrons in a wave-like manner. So gravity comes in, and it's absorbed and re-emitted. So it's never the same light that comes in. It's never the same gravity that comes in. All of the electrons making up yourself absorbs that incoming primary, which then diminishes to zero, and then a secondary crescendos as an equal and opposite reaction, and that process happens at the velocity of c. So it's like at the velocity of c. So you have a prime. So the illusion is that a primary comes in and distorts, and relativity views that as the space-time curvature itself, but this classical physics views it as emissions of gravity. Back to John Searl, when this device absorbs more electrons than it can emit, you have the compression of electrons because this is absorbing them in 3 dimensions, and then it is converting them into 2 dimensions, only outputting them like Saturn's rings, planar, radially. So you have absorption in 3 dimensions and then output in 2 dimensions. So now you have an entire orthogonal axis of internal kinetic energy of electrons being restricted to flow like a laser. So now you have high velocity electron pairs like Cooper pairs being jettisoned from the equator of this ring-shaped device, which then those Cooper pairs split at the awaiting pickup coils. Those fermions then migrate back to the positively charged neodymium core, where they couple again, and then they cycle through the unit, and then they split, and the cycle repeats. Analogous to a hydroelectric dam on the quantum scale. So you have water raining into a reservoir, electrons coming into the neodymium. The valence electron is easily stripped because there's an extra electron in the neodymium atom. So then that goes through the device itself and then splits, analogous to the water being evaporated on the other side of a hydroelectric dam as runoff, which then forms clouds, rains back in the reservoir, goes through the dam, spins turbines, evaporates, and you have a cycle. But this is happening with the internal kinetic energy of electrons themselves, with all of the surrounding randomized energy that we take for granted as temperature. It's not heat. Heat is treated as a flow like the Carnot cycle, but this is dealing with the total amount of surrounding energy in an open system. So this machine or device can exchange heat, work, and energy with its surroundings. Matter and electrons could come in and leave. All known electricity is pretty much made by, you have a battery, it's storing electrons, and then you deplete, it's leaving, they're leaving. And then as the electrons leave, that's it. Everything heats up, and then you have no more energy in a closed system. Nikola Tesla discovered alternating current. So rather than having electrons leaving, you're just shaking them in place. So now you have alternating current. John Searl discovered a method of bringing in new electrons as old ones leave. But you can do that where you're bringing in new ones faster than old ones can leave. So you're bringing them in 3 dimensions. They can only propagate in 2 dimensions as they output. As they do so, the device starts cooling and cooling and cooling because the energy has to come from somewhere. The first law of thermodynamics has to be abided by. But the second law of thermodynamics only applies to closed systems. So the energy comes in, and this guy was trying to power his house with this energy. And when it absorbed too much energy, it developed gravitational anomalies, he claims, and that's why it blasted through his roof. Years after experimenting with this, he learned how to control their energy and power his home and regulate it up to a point. And so all of the efforts in the past were to do this as a hobby because John Searl just loved to do this as research. But we are trying to do this to power homes and industries. And imagine an electric car that you never need to plug in to charge. It's always charging the batteries in a Tesla car. Or you can replace the batteries altogether, but you would have to scale up the mass of the unit. So the more mass, the more energy that you're able to harness and output. So there's limits to everything. Even though it's like taking a teacup in an ocean. If you have a whole ocean of energy, there's still a limited amount of water in the ocean. There's still a limited amount of energy in the sun. But we're not going to be able to use all of that, right? So it's seemingly infinite, seemingly limitless. But there are indeed limits. But to us, it's more than we can hope for.
It's an interesting idea. I'd like to look into it more. I don't know enough about some of like the fermion paradoxes from the macrocosmic scale at this point. I think a lot of things from my understanding have changed, with developments in terms of like pentaquarks, if people even accept what they accept anymore is true or false. I don't know. But
I lean more towards the structured atom model, which was proposed recently by a group of physicists and chemists. The Rutherford Bohr model of the atom with the orbiting electron, the ball model that was really outdated by the 1950s, but it still depicted an oversimplified.
That's what I got. I was taught.
Yeah.
Principally,
California. Everywhere else got taught that. I don't know.
Oh, the textbook mafia.
But
Santa Cruz. Anyway,
right.
But like
the textbook mafia, man.
Yeah.
Yeah.
I'm outnumbered. My gosh, I gotta get out of here.
So we got lots of fantastic, extraordinary claims that require extraordinary evidence.
I principally like the idea, though, of keeping, because, all right, first things, I like two things. One, destroying and disproving a mistruth. But the second thing is not throwing the baby away with the baptismal water, So, like, maybe the word gravity we can keep. Maybe if we just find out what it really is, we can use it. We can use it again. So, all right.
Because I take, there's electrostatic attraction and repulsion. You got magnetism. You have centrifugal force. You got acceleration, you got Casimir force, you got eddy currents, you have acoustic and ultrasonic levitation, you got ion wind. All of those things simulate the effects of gravity, but none of those things are gravity.
And you don't have dielectricity.
No.
Right. You taught me that, Jason.
Materials. You
said
dielectric
dielectricity is a theory created by Ken Wheeler.
Correct. And Eric Dollard.
Hey, don't lump Dollard in.
I love it, but no dielectricity, and the sun is not hollow. It's made of metallic hydrogen.
Dielectricity helped me understand gravity better, as it was like this electromagnetic, more electromagnetic than anything else, just the way that it was explained. But then, whatever. I don't believe in it anymore.
Look,
I believe in gravity in a new way.
Eric Dollard is a respectable, crazy, homeless man who lives in the desert. He's nothing like Ken Wheeler. Don't bring him to that level.
No, he's not. Ken Wheeler made up his own terminology. Ken Wheeler's a good dude too.
He wrote a book. I haven't read it.
Secrets of Magnetism. I
feel like all my life I've had things I've wanted to say, and as a good Christian lady now, I can't say them.
I wrote an article about Ken Wheeler's terminology and the misconceptions of the magnetic ferrocell. When people put magnets on this ferrocell with LED lights around it, you see these lines of magnetism, and they think that it represents magnetic lines of force. It's not. There is no magnetic lines of force. Magnetism drops off as a smooth gradient, and you're seeing the LED lights bend and refract and diffract through the fluid. So there's like misconceptions there, and I'm very.
Have you told
technical.
him that? Like,
Oh yeah.
has
Oh,
he
yeah.
commented back? Or
Oh
what?
yeah, I've commented on for years. I'm a pedantic troll, man.
Oh my
I'm
gosh, that's
horrible.
great.
I'm
He's,
horrible.
I mean, he's crazy. But like, I used to watch his videos, and I was like, wait a minute, I get that now.
Yeah, dialectic
And
is a
then
material,
I was like, wait,
not
do
a
I get
force.
it?
Thank you.
Do I get it?
So
And then I'd have to-
gravity is real. It's not imaginary. Gravity is a force. It is an emission which propagates.
Is that why
like
I'm not
light.
floating off the spinning crazy ball?
But there's an
in the air?
illusion of being able to
Hold on,
measure.
hold on. Thank
What?
you,
What are we
gravity.
doing?
I would be falling right now. I thought that was gravity. Just keep is that just keep me here?
Exactly. Jump up and you will come back down. That's not debatable. But the mechanism of why and how that happens is debatable. But
That's like
I
the
don't think it's
opposite.
Because I
don't think
weigh
it's buoyancy
something.
either.
It's like
I
the
weigh a
opposite.
lot.
It's like the opposite of Chumbawamba. Sorry, keep going.
But if there's a lot of hydrogen and helium like there is in the upper atmosphere, I would just float if I jumped, and that would not matter if there's gravity or not. It would just be like me and the hydrogen and helium. It would probably, I don't know. I couldn't breathe. I didn't need oxygen too, but yeah. Anyway,
So like, let's see where. But yeah, what
enough said by
what
me.
do you? What
Yeah,
questions
it's
do
like
you
a
got?
video game, Jason. You just have to deflect. Just go like this
All right.
and just
All right.
use this, and then you just keep going. You get it.
It's all right.
So you're talking about
Uh,
you're talking about gravity.
yeah.
And you're talking about So one of the things you said was that all the ways we've used to disprove what people have lied about gravity being, electromagnetic spin states and things like that. That those are not gravity. You said that those four things are not. So why are they not good enough? Why are these magic tricks not good enough to describe gravity? Can you explain that?
I think it is an illusion. I think gravity and light are absorbed and emitted by electrons. Electrons are not a particle. Don't really know what it is, but it is around and in atoms, acting as like an electric glue for atoms. Electrons are electricity, but it's not a particle. It's like a sphere of energy. Okay, we don't know what it is, but it has the ability to absorb and emit electromagnetic radiation. Light and gravity is absorbed and emitted by electrons, yet light and gravity itself is not electric. So that which comes from electricity is not electric itself. All the light coming in to your eyes is absorbed by the electrons making up yourself and then re-emitted into your eyes. So it's never the same light coming from the sun, coming from the light bulb. It's always
It's
brand new light.
It's literally like Oculus. Yeah, it's the worst thing.
It's a brand new light at every point of interference. Relativity says it's the same light bouncing around forever within the same frame of reference. It's not. It's an illusion, because by the time the light comes into, let's say there's a really fast light coming into you. If the light coming from a flashlight being held in my hand is not the same speed or velocity as the light coming from a flashlight moving towards away from you. But the illusion is that by the time that light comes and hits you, the electrons of yourself will absorb it and re-emit a brand new light relative to yourself. So you can only measure the light re-emitted from yourself. All the light you ever see is the re-emitted light from yourself. All the gravity, if you ever feel, is the re-emitted gravity from the electrons making up yourself. So it is impossible to physically measure the incoming velocity of any primary. It is impossible to measure any emissions of gravity from any source, because you absorb that emission and re-emit it just relative to the electrons making up yourself. You can't measure the emissions from a larger source because you're just measuring a re-emission. So there's technicalities to.
So like if I light a, let's say, in the movie Zorro, and there's a big path of black powder on the ground, and I light it on fire, and it's different black powder along the way. Is that kind of what you're saying? It's not the same. It's not like, it's not like a pneumatic tube of energy going across. It's like new things.
It's a sequential reciprocation.
Dominoes.
Like the bulbs on a Vegas sign. The bulb isn't actually running around the sign. This one's flashing on and off, then this one on and off in sequence.
That's Gestalt. That's how they discovered the Gestalt theory, by the way.
Yeah.
Max Wertheimer was on a train and he thought the dot was moving, but it was just going to perception.
Yeah.
Sorry. That's cool.
So, yeah,
Digress.
there's just a lot more to that. And I have presentations about this, the rebirth of classic physics, of time, light, and gravity, based upon this work of Dr. Edward Dowdy. So he reformulated classical physics equations in 1991 to yield the same predictions and solutions as relativity, but without needing space-time, without needing time dilation, no ether, no looking back in time. No, it's a completely different interpretation of everything. And so when I'm looking at how atoms operate and the absorption and emission, there's no ripples that are propagating from planet to planet. There's no literal gravitational waves. There's none of that. It's absorption and emission in a wave-like manner from the electrons making up yourself, from each observer, from every measuring device.
And
So
magnets have a strong impact on that. Like
magnets can facilitate the flow of electrons, and electrons absorb and emit gravity. So if you have the electrons flowing in a specific wave, then gravity can be produced in a specific wavelength.
And where is
I'm kind of a fan
Where's
of
the
that
gravity
idea.
coming from again?
Well,
Gravity is coming from electrons in a ratio of coherence to incoherence. So you have disorder and order, and you have different ratios of that, and then you have all these
The
electrons
balancing of chaos.
I'd
So,
really
but
like
in a high pressure state, they're forced together so much that they even out, like from van der Waals forces and from other stuff. So they create a geometric grid, like a chain link fence, like graphene. But then outside of that boundary, all of that energy that's pent up has to be released, and then that's where you get all of the emissions of exotic stuff happening.
Oh, yeah. I'm glad you're having a good time. Arbolero. Yeah, okay. Arbolero. Your name is hard to say for some reason.
Arbolero.
We'll probably need to get
graphene.
we're probably going to need to get Jason to debate with Jeremiah a bit on spin state. But do you want to talk a bit about why spin state? More specifically, why spin state isn't enough, to replace these ideas? Because you're talking about symmetry of electrons, but isn't at the end of the day that's just having to do with the density of energy in material. So it's all spin state.
And then once you go to measure it, then you get a diffraction pattern, and then you get electron configurations because you're measuring it, and then you're getting the re-emissions from the measuring device, which is representative of the frequency of interference from the source. And
so kind of infers that it's not really spin, it's the domino thing again.
And it's impossible to measure directly because the active measurement introduces interference, and the interference produces re-emissions, which is actually detected. So there's illusions.
Right.
Everything's illusions.
No, it's interesting to imagine, if you're looking at a domino effect from that far away, it's going to look like a line, So yeah, it's something that has to be further experimented.
Somebody asked about the vacuum of space. How does gravity keep the gases in the sky? Space is not a vacuum. Space is a state of less pressure. There is no suction in space. When you're in, let's say you don't believe the Earth is flat, okay, and you believe that there's a space station, right? Okay, so let's say that there is a state of less pressure up there. What happens if they were to open that door? They would not be sucked out into space. They would be blown out into space because there's more pressure inside of that compressed tank of air that is the space station. And when you puncture a hole in it, you're letting that positive pressure out. So you're blowing that pressure out into space. So there's no vacuum out there. It's just a state of less pressure. So then you have gravity, which is a force, and an aberration effect, and then you have gravitational shadows and re-emissions. So, and then you have buoyancy and electrostatic cling. Then you have adsorption, and you have all these other factors combined, which keep the gases clung to the surface of Earth like a film.
Say you believe in the other Earth, though. I have a question then about the atmosphere. And so if there is a space station, they say it's in the lower atmosphere or in low Earth orbit. Still, low Earth orbit. And in the upper atmosphere, and trying to get data on, again, hydrogen and helium, and the amounts of hydrogen and helium in the upper atmosphere is really hard. There's 2 websites that I could find that were there's an abundance, because I'm trying to think of how things would stay up without gravity or without this, whatever space forces. And to me, also, it just seems like once you get higher, there's not going to be the oxygen, but there's going to be hydrogen and helium. So things should be easily lofted or stay up, or does that change the electrocharge, or
Yeah,
what does that do when you have
there's
tons
a
of that? Because that's where
there's
it
a there's
goes.
a gravity. Like if you light a candle, you see the light drops off and gets dimmer and dimmer away from the candle, right? It drops off according to the inverse square. Same with a speaker, same with heat, same with electric potential, and same with gravity. The gravity drops off according to the inverse square away. So there's just less gravity away from the planet and the source because there's less mass and less electrons to absorb and re-emit it. So when you travel in a little spacecraft in between the planets, there's nothing much to absorb that incoming gravity and re-emit it except the electrons making up the spacecraft and everything, which isn't much. So there's technicalities, I guess. Oh, muted. There we go.
If we launched up in the upper atmosphere, it's more likely to be able to satellite or to stay up high for a longer period of time with hydrogen and helium. No, does that have
you
any?
still have to have propulsion to keep you up there and like, you have to have a tank of energy to keep you up there. When that's expended, you come back down.
Satellites.
No time waves.
Rotating.
Time is a constant. There are no time waves. No 5D. There's no 4D. Only 3D Euclidean space. I'm going to shatter people's hopes and dreams. No time travel. What is a gravitational shadow? Well, if you know about Newton and the prism and the colors through the rainbow of the colors of the prism, there was a guy 125 years later named Johann Goethe, Goethe, spelled Goethe, but it's pronounced Goethe. And he discovered that there is a shadow for every color. And there is a spectrum. There's a light spectrum and there's a dark spectrum. There's an absorption spectrum and an emission spectrum. So Newton's spectrum is emissive, and the Goethe spectrum is absorptive. So if you have just a blue light, block that blue light and you'll get a yellow shadow. If you have just a red light and you block that light, you'll get a cyan shadow. If you have a red light and you block that, you'll get a green light, excuse me. If you block the green light, you'll get a magenta shadow. So there are colors, and then there are shadows of colors. So light is an emission, but you can have a shadow of that color, right? So there's a color and there's a shadow counterpart. So if gravity behaves like light and light can produce shadows, then it's logically to assume that gravity might also produce shadows, and it's not just gravity coming in from one source. It's being re-emitted from all directions.
Is that coming from the sun then too? Like
absolutely, it's the main source.
Gravity is.
It's the main source, but it's not coming from the nucleus of the atoms. So that the gravity is associated with the density of the atoms, but that's an illusion, because the more density of the atoms and the stuff, the more electrons that you have. The more electrons you have, the more potential for gravity. So they associate the gravity wrongfully directly with the nucleus of the atoms, but really it's absorbed and emitted by the electrons.
That's how the sun stays up there, because it's just got lots of that.
Well, stays up there.
It's propulsion, right?
It's it's not a ball of the sun. The sun is not a ball of gas, though. That's another huge misconception.
I was thinking it was like a great ball of
plasma,
fire and energy, like how you were just describing it.
Well, plasma can also be a liquid and a solid. There are liquid plasmas and solid. Plasma is usually thought of as ionized gas, but in high condensed matter physics and high energy physics, you can have like liquid metallic hydrogen. That's what the sun is mainly comprised of. So you have hydrogen gas that is compressed so much it forms a liquid. But what happens if you compress a liquid? It's incompressible, right? You can compress it so much that the electrons they share all of the common. So rather than each atom having electrons, all of the atoms now share electrons collectively. And that is the definition of a metal. So if a material has its atoms sharing a common lattice with the rest of the atoms,
Like
that's a
force
metal.
field. That'd be
So
like a
when you
force-
have hydrogen compressed into that state, you have metallic hydrogen, and the hydrogen becomes a metal, a liquid metal. It's not mercury. It's liquid metallic hydrogen.
What does it look like? Like
It's
what?
black. It looks black,
What?
like a block of graphite. It looks, because graphite and graphene is
So is it a fuel
it's
then,
a
too?
hexagonal lattice. It's a cubic hexagonal lattice. There are studies from a man named Dr. Pierre-Marie Robitaille, who has done these studies for decades. He took out I think it was a New York Times magazine in 1990 or something like that, about how the sun is a liquid, and that ad cost him $100,000, and he's been doing work on that ever since. And Dr. Robitaille is the reason why MRI is possible in hospitals. Originally, the scientific community said that MRI had such a strong magnetic field it will fry a person's brain if you put him in there. Dr. Robitaille said, no, there's a flaw with the math. There's a flaw with the whole theory of Kirchhoff's law of thermal emission. And he corrected that and said, the person's not going to be hurt. The theory is wrong. So he rewrote the entire theory, and now people can use MRI machines.
What did he get? Like some people to test on? And the first, I wonder how many he did.
Probably animal. I don't know, but he corrected the theory itself and showed that, wait a minute, it's not going to hurt people. And indeed, it's been used for decades, and he is to thank for that. So he applied that same methodology and scrutiny to the model of the sun, because he's a spectroscopist and radiologist by trade. So looking at the sun in different spectra, he said, the sun can't be a gas. If you put gas into a neon tube and you excite it, the plasma is one specific emission. It's like they have emissions lines of, you only get certain lights and colors of lights from certain gases. Only condensed matter can produce white light in a continuous thermal spectrum. So the sun is made of liquid metallic hydrogen. It's not made of gas. You can also see ripples on the surface of the sun. Ripples like throwing a pebble in the pond. And that can only happen in water and condensed matter and liquids and solids. Can't happen.
So is it super light? Like, okay, liquid.
It's a hydrogen metal, but it's a super
it
light.
floats.
It's like 10 to the third grams cubed.
So
the sun is a mass of incandescent gas that is floating in out. It might be giants, but also, yeah, like density. So do you think that the density makes it liquid, or is that not what you're saying?
It's a liquid metal
because of the density.
Okay, because
metallic gas.
Metallic gas.
There's gas around in the atmosphere, but the surface of the sun and the majority of it is liquid.
Because that's the coolest part. Yeah. Okay.
But now when relativity says that light bends around the sun, because they think the sun is made of gas, so they attribute that light bending to gravity, but gravity doesn't affect light at all. So the bending during a solar eclipse and the bending of light is due to a different refractive index due to the metallic hydrogen being condensed matter. So like if you stick a straw in water, the straw will change position at the surface of water because of a different refractive index. Same during a solar eclipse, you see the stars change position during a solar eclipse without distortion. Relativity says there should be a progressive bending with distortion, but there isn't. It's just a change of position without distortion. So they attribute it to gravity bending light, but classical physics says it's just refraction. And the same equation for relativity saying gravity's bending light, it's the same equation for classic physics saying it's refraction, but only at that surface of the star. So relativity invents a bunch of other equations to suggest how we should see light bend, this far away from the sun and this far away from the sun, but that's never been observed. They only have computer simulations. They've only seen light bending at the surface of the sun and the surface of stars. Microwaves and X-rays deflecting only at the surface.
What about like laser tests? Does that not count? Like if
yes,
done, like,
it does
bending?
count. And they can see it's like a lens, a physical glass lens. A laser beam does not progressively bend towards the lens. It just gets to the lens, boom, and then it bends only at the surface. Same, you have the deflection at exactly 1.752 arc seconds at the surface of the sun, at the Gaussian surface. And there's a principle of reciprocity. The light comes in at an angle of incidence, and then it is not lensed, but it's refracted at the
Well, I
equal
guess
and opposite.
if it's a liquid, wouldn't it also be refracting from the liquid? Is that like the point that it's kind of
And you
similar
can
to a
see
liquid
that
lens?
during the solar eclipse, but they
Okay.
attribute that to gravity, but it's not. It's
Gaussian
refraction.
lens from the liquid. That's interesting. Yeah, that makes sense.
Yeah. Yes,
I like that. That's good.
there it is.
And so that's all the anti or gravity stuff.
That's right.
And the
No, that was the pro
Searl
gravity.
stuff.
That was the best
That was
gravity
pro gravity.
apologetics.
Sorry,
The best
but
gravity
he has
apologetics I've ever heard.
it's not.
So it's not
anti-gravity.
anti-gravity. Anti-gravity is like canceling gravity. You're not
I
canceling
want to
gravity.
change it.
You're
Yeah,
competing
I wanna
with
change
it.
the title.
Yeah,
Yeah,
you're
Propulsion?
competing with gravity.
This is gravity apologetics.
But
it's
the
good,
next
it's good,
subject
I like it.
is also, if we can just start to tap the surface there of
Yeah.
nanobubble and ozone nanogas, ozone nanogas technologies, because that stuff's really interesting.
Or just the nature of it as well, too, because like
So-
aerogels exist. We're just trying to make different symmetries of aerogels. They've been around. Like that's what nature is filled with aerogels.
I like doped aerogel, so they're a little more robust.
Doped aerogels are
You know.
pretty dope.
Yeah. You're
Really?
right.
Yeah.
So nanobubbles are a gas or a bubble that's 1,000 times smaller than a red blood cell. Okay, so the bubbles in your Coke or your beer or your champagne, those are micro bubbles that form, and then they rise to the surface and they're lost. Or if you have like your sink and you get your tap water and you get cloudy water and you get all these bubbles in it, and they rise to the surface. Those are micro bubbles. Nano bubbles are like 1,000 times smaller than that. The nano gas. So you can compress different gases like oxygen or hydrogen or ozone as a dissolved gas in water for huge, amazing, fantastic benefits, like unbelievable. You can soak oysters in ozone nanobubble water for 24 hours. No more viruses, no more bacteria, completely clean, no risk of any sickness. You can disinfect surfaces if you shine UV light on ozone nanobubble water. You can turn that water into a mist or a fog. There's still bubbles in the droplets because they're so small, and it acts as a disinfectant without need for chemicals. You can inject water with so much oxygen nanobubbles that freshwater fish and saltwater fish can be in the same tank. And they have this displayed in Japan. This technology is mainly only in Japan. Now, there's a American company called Moliere that is recent, and they have been coming out with devices, and they clean out algae blooms and red tides from lakes and ponds. All that stuff in the lakes suffocates the fish and the life in there, and it's nasty. You have nanobubbles in the water. The nanobubbles latch onto the impurities, change the buoyancy of the impurities. They rise to the surface. You suck off and suction the surface, and it's left with clean water, and all the fish are happy, and you can drink from the water right there.
And didn't you say you could ship them frozen and they'll stay alive?
Yes. Oysters you can ship in blocks of
oxygenated?
ice. In oxygenated water, you can ship them in blocks of ice, ship them, thaw them out on the other side, and they're still alive, and you can have clean water that way through restaurants.
Another health benefit, just personal benefit, was drinking the hyperoxygenated water. You said there's data on counts going up, red bloods.
There's these thermoses with electrolysis at the base of it, and it's like two metal plates, and they have electrolysis, and it makes hydrogen bubbles, and then you drink the hydrogen bubbles in your water, and they're hydrogen glasses, hydrogen thermoses or something. It promotes benefit because there are hydrogen ions, and you have negative static electricity in and around those bubbles, and you can drink that and absorb its benefit. Because when you compress, let's say you have oxygen and you compress oxygen, normally there's going to be harmful radicals that are ejected. And if you breathe that and you're around that, it's going to hurt you. But in water, those harmful radicals will bond to the salts and electrolytes in the water to produce a net negative electrostatic charge. So you can't have negatively charged water per se, but you can have negatively charged gases in the water on a nano state. So then you drink that, you pour water on the plants with it, and plants don't lie. So you pour this water on plants, they grow faster, you get more food with it. Can't lie
so
with
that they have the experiments. That's the only thing they really have on for
oxygenate
stuff they're showing is a couple plant growing experiments. But yeah, it would be sweet to be able to drink that. You think you might live longer if you have like super oxygenated water?
Yeah.
Probably
Or
good
have
for
a,
your
I would
red
take a
blood
bath.
cells.
What would
Yeah,
happen if I
exactly.
took a bath in one?
Exactly.
That'd be sweet.
Exactly.
Lots of O2.
Nano bubble bath.
Yeah, there's lots of
Don't bathe in the
lots of
ozone
benefits.
one. Or maybe
No, you know what? Well, yeah,
don't
just the
know.
oxygen for me, please. But you can bathe the seafood. If
Maybe
you're
that
gonna
is
eat
a
it in
good way
the
to. You
ozone.
don't need soap. You just like spray yourself
For
with
laundry.
like the
For laundry,
ozone
you can do that.
gas and do one quick UV zap, and you're like, I'm clean.
Way
Yeah,
too
they say
tank
when the
girl.
water has like a really
No, we're not gonna go.
when the
not
water
that
has like a
far.
really high pH, they say you don't need like you don't need
I'm
soap.
just
This
trying to
is
capitalize on the
literally tank girl.
technology.
I don't want tank girl
Capitalism.
Use
feature.
soap anyway. Just do it anyway.
Let's capitalize on the technology.
I'm just imagining Lori Petty and tank girl, and she's like covered in the powdered soap, and there's no water. Thanks a lot for that.
So there's another thing about this magnetization process with the John Searl thing. You can equate it to like cymatics. You put sand on a plate and you vibrate the plate, and it makes the geometric patterns with the particles on the plate.
Ooh.
Now combine that with the concept of magnetism. So you have cymatics with magnetism, and that's like an analogy for John Searl stuff. And anytime that you are having order and mimicking order, like nanotechnology, like you have a nanotubes and carbon and graphene is more conductive than copper. If you look into like the atoms in the sun, they say that they are evenly spaced because there's so much pressure. Everything is like stacked evenly, like graphene, evenly spaced and ordered. So in a high pressure state, you have coherence and you have order. And if you mimic that through engineering, you can reap the benefits of that order as if it's in a high pressure state, and you get anomalies. So that's why things, when they are made and engineered super, super ordered, you can reap the energy in an ordered manner.
That reminds me of what we were talking about earlier about John Searle did the BBC interview and the stills from that, somebody posting it and having their channel taken down from just like a photo of it, that it's some heavily guarded info right there of that interview. And you tried to get the interview from the BBC?
So I trying for like 8 weeks to contact the BBC because in their archives, it is listed that they have footage of them, of John Searle building his device and experiments, and they did weekly updates on John Searle for over a year. So I'm like, and that was on local access TV in Britain at the time. So that was like on 8mm reels of footage. They didn't.
What year was that? Did they air it?
That was in the 60s, probably like 65 to 68.
Okay.
So I was looking in their archives, and they list it as having, John Searle's levity disc, an episode. They have at least a few episodes, master copy, X00, whatever number. And I took a screenshot, or I have that in my album. And so it's listed to be there. But when I contacted the BBC, they said it's just not in the archives. It's listed to be there, but it's not there. Of course. Fantastic claims requiring extraordinary evidence. And
I thought it was just one documentary. Yeah. They aired many episodes all year.
Yeah. Weekly pieces for over. So let's say there's at least 10. Okay. It's weekly pieces for over a year. That's 52, right? At least. So let's say there's just 10. 3, 1. Just let me see one, So the footage is claimed to exist. It's according to the BBC even. So I would like to see that because I've never been able to see it. but that's the claim. So that
Andreas, can you
PVC
find that? You can
technology-
usually find just about anything online, or except for Bryn Tintin K9.
Oh my God, pull
Sorry.
that up. Yeah, I cannot find this
Pull that
one
up, Jamie. Pull that up.
I've been looking for Steve Buscemi doing White Tornado on Saturday Night Live forever, and nobody, and I
Oh,
can't
here come
find
the
it.
requests. There's
I
3
couldn't,
now,
I couldn't
Andreas.
find a French Canadian
Sign magnetics.
dog
I like
show from 1980s. I'm sorry.
90s.
Do you want
Anyway,
me, Jason, did you want me to try to look for something? What was the thing you want me to
it's
look
the
for?
best shows on the
What can I
Most
look-
guarded-
What would I,
Look
The most
for
guarded
John
footage.
Searl.
The-
John
Yeah.
Searl,
John Searl
Yeah.
Levity disc.
Levity disc,
BBC
BBC.
master footage.
yeah, so they
Is that
didn't.
on YouTube? I should look that or where?
No,
on Google?
archives.org.
No, in the
Do your
BBC
magic. You
archives.
can't find it. Like, it's
It's not gonna
guarded.
be on YouTube.
Yeah, you have to try your little special places.
I'm the one who
Uh,
uploaded most all of John Searle's material on YouTube, and YouTube deleted it all. My 2 channels of 16 years were deleted because they labeled all of my videos on magnets and challenges to relativity and gyroscopes. They labeled all of them medical misinformation.
Ooh.
Yeah, it's
Drop
true.
a
'cause-
magnet
you're
down
on
a copper
TikTok.
tube. It's medical misinformation.
Yeah, your
Wow.
TikTok's booming, right?
was.
You want to see
Yeah, go to
the?
your
I got
TikTok too.
the John
It's a good
Searle story
place.
DVD, the flying
pitch
disc.
that.
That's mostly what I could find. I can't find much more.
You mean
There's
this
like,
one?
yeah,
Yeah, they'll let those experiments slide
I
on
come
TikTok.
prepared,
Yeah.
bro.
yeah. So we'll have to check out the DVD. but-
I was the
is that
first
one?
person to get that DVD in 2008. I bought.
Do you
it.
have your
bought one.
content that was deleted? You have that content?
Yeah,
still?
most of it.
All right.
They,
Well, why don't
they
we put
deleted
that
like
on,
hundreds of videos.
You should put your content. I can help you put on a perma-web storage token so it can't be deleted, and then
Yes,
it can be like
please.
re-updated. All right, we'll talk about that
Alright.
after this. Yeah,
Yes, because I have it
I'm
on
a big
Rumble
fan.
again.
I'm a big fan of doing that.
Right on, man. Yes, excellent. Put it on. I tried to do it on Odyssey, but they said I didn't qualify.
What?
Oh, you have to
Really?
have a certain amount of subs. Do you have
I
300
had
subs?
250,000.
You need 300,
What?
right?
300 or
bunch of-
300,000.
No,
Yeah, you don't have
you don't
to
need
do
that many for Odyssey.
Oh,
maybe that was
Odyssey
early on.
Maybe Odyssey
You needed
changed their rules
300
now.
to connect
No,
them
it's
before.
just me. It's just your boy.
Yeah,
I
it's
get
your boy.
special
That's
treatment.
terrible.
That's why I park in handicap.
What?
No, we can fix this. We can get you on something that'll work. Quick, what's it called? Corksel? Whatever. There's like just like a perma-web thing that's really amazing now. Yeah, and then basically it gets distributed to all these different places, so it's never deleted again. So that's pretty much the solution now. Yeah,
Use
you're
all
gonna have
the
to
help I
drink,
can
son.
Nano
Right.
bubbles.
Yeah, that's right.
Well, the nanobubbles, though, I mean, in general, we have already nanobubbles that exist all around us. Like, isn't that kind of the point? But we're trying to
No.
engineer them.
No, there's micro bubbles, but in order to compress them, it
You
requires
should
a lot
open
of
up the
energy.
factory and show what the machines look like.
There's like 250
Go to
PSI in a
Molear,
nanobubble.
Moelear.
Yeah, mole.
They
AER.
you can buy a machine if you're a business for them for agriculture, but like there's so many other things it can be used for, like it is in Japan, used for everything. And you're gonna start to see people probably living longer.
It's crazy
um,
amount of benefit.
but,
I'm
like,
telling you, there's like
you know,
dozens
thinking
of
about
commercial applications.
Having carbonated water that's carbonated for a very long time, forever. Or you have a permanent
forever, but
carbonation
let's say
machine
for
that's
months.
just like, but you could have a personal carbonation. It'd be easier, and it would be like uber carbonated.
Yeah, that's the thing is the nanobubbles are so small, they have neutral buoyancy and they don't rise to the surface. So like the nanobubbles stay in the water for months. So you could carbonate your water and have like your soda carbonated for months. You don't want to probably drink that if it's months old, but it'll be carbonated. It'll be carbonated algae syrup, but it'll be carbonated.
Yummy.
Ew.
Thank you, Mythoclast, for another Arborello, and then Arbolero. I don't know why I have a hard time with that.
Arbolero.
Arbolero and Mythoclast.
Wait, what did he ask?
Oh, they just gave us
Mm.
both. They gave us members,
Woo.
free memberships. So that was very kind.
Time? Thank
Yeah.
Wow.
Well, Brittany, more question?
Yeah. What you got?
Questions?
Put me on the spot.
Well, no, just there's a lot of practical applications. So you're talking about like fish, personal aquariums, and what I don't know if it was the oxygenated or the ozonated.
Oxygenated or ozonated.
That one, you dump that into your aquarium, and then it like all the other stuff rises, and it's easy to clean your.
Well, that's the thing is the
Fish
nano
tank.
bubbles will will latch on to all the impurities in the water and then rise them to the surface. And then you'll have all this nasty stuff floating at the surface. Then you clean that off and you have a beautiful, clean tank of water.
So what happens when you drink it then? All your impurities are like, come on, a burp? No,
Maybe.
just kidding.
Maybe.
I'm pretty sure the stomach acids would be different than the aquarium, maybe. But I don't know. I wonder the impact of that. I have to look deeper at the research. You said there's a bunch of research and case studies on physical health, or what was that from Japan that they had?
Not just in Japan, but elsewhere on hydrogenated water, oxygenated water, restoring liver values, kidney values, even with mice and rats, helping with arteriosclerosis and cancer therapies. The nanobubbles seeking out the tumors, or at least injecting it directly into the tumors, and it
really
cancer
They've
treatment
done the
with
cancer
nanobubbles.
Because I suppose if it's trying to get that's crazy.
Yeah,
it's awesome. But and so liver, I'm sorry,
liver treatment, liver values restored, kidney values restored. And there are case studies that I've seen. I have papers on this from a man named Steven Settlemyer, who started a company called Divinia Water. And there were claims of people drinking this that would need a kidney transplant or a liver transplant, and then they ended up not needing those transplants. And they attributed that with drinking that water.
I told you how my friend recommended it, and he's like, Julia, you got to try this water. It's like blow. He's like, it's like liquid Coke. And he said it energized him, and a lot of health issues he had, he saw rapid results in less than 10 days.
But you can't, it's difficult to make those claims,
Well, so many of us are dehydrated though. And like we're not having, and then you get into the living structured water and how important that is.
Settlemyer, Seddlymyr, Settlemyer.
Do you know anything about vortexing water then, or what does that charge the water, or does
that's an attempt to make it says water in motion is like motion is life, water in motion is living water. So you want to keep your water in motion, and if you're going to drink from water in nature, you want to drink from the fastest part of the stream, and hopefully there's nobody peeing upstream. Pay attention to that one. But you want to always drink from the fastest part of the stream. You want to keep your water moving, and
spring water. You could go on a site and look up your local springs, and like that's the most ideal is spring water.
And talk to your water, like Julia was saying. That was awesome.
Weird when I'm like, I drive somewhere with like 5-gallon buckets, and I'm like standing at the side of a cliff, like get water out of the side of a mountain, and people are driving by.
That's right.
I have a question.
I'll do it. But...
So let's say there's a bottled water for sale, and it had like this little vortex thing at the top. The water came above it. It went through this thing. That thing was disposable, and then now you have this vortexed water. Is that something that's would legitimately help people? Does it matter the material that it's going through? Does it need to be maybe if it's like that liquid metal hydrogen gas stuff, and it's going through that kind of vortex? Now you have like this supercharged water, and then you talk to it like Julia told me, and now you have like super magic water.
Well, you can
that worked, Julia. I did it one time, and it was so weird that it worked that I didn't do it again. I was like,
it's amazing. Like Dr. Emoto, he proved that. Like he had astounding experiments showing like how important it is of what you say to your water. But Vita Austin is amazing of what she showed. She would put images by the water and freeze it, and it would duplicate the image. And like she said her name, and it and froze the water, and it showed her initials in the water, like water's consciousness, and water mirrors, it reflects back to you. And then you think of the water scrying, and Nostradamus did that. Edward Kelly, he used water, and he put a crystal in it, and he would look at the water and scry. And so like there is so much power in water. And so how you treat it's very important. So speaking to your water is anytime before you drink or anything, speak to your water, say loving things. It really makes a difference. And
she said out loud. She said, Julia said this one day, and I was like, and she was on, I don't think I was on, I was just watched you. And I was like, all right, I'll do it. I'll buy into it. And I felt super silly. And I was like, then I thanked the water at the end of it because I was like, this water is going to make me feel super energized and good. And I'm going to appreciate it. I have gratitude for this water. And I like did a little circle thing. I'm like, thank you, water. So anyway, felt ridiculous. Took a sip. And I felt like supercharged. It was weird. The water had to happened to be probably a little bit chilled. So it maybe had an impact. But I felt the surge like go through my body. And I was like, oh, Julia. It's like, and then I'm like, that's placebo effect. She planted that in my brain, even though you didn't give me those details. But it was really kind of bizarre. So then I have not talked out loud to my water since, admittedly.
You should do it. You should
I don't
start
wanna
doing it. We
have
should
that
all be
power right
doing
now.
it. We should
I
all
need
be
to
doing
be
it.
in a what else?
You know what
can
I'm
it do?
drinking?
You
I've
know?
been
I'm
drinking.
like, I'll drink this water
Jason,
and
he actually sent me some Willard water. That's what I've been drinking like the last week or two.
Oh, you have. Oh, excellent. See, that's
what's
doing your
Willard
homework.
water? What is
Excellent.
The
that?
wonderful
What's that?
Willard. You want to explain to them what Willard water is?
Yeah, what the wonderful Willard water is. The Willard Wondered
What?
water. It was made by Dr. John Willard, who is a chemist, and he okay, skeptics have rightfully said that you cannot change the structure of water that you drank, and then you're getting negatively charged water that you drank in structured water. It's like that only happens at the surface of a material. You get this difference of negative water than the rest of the water. So people are trying to wait a second, here's a good book, actually.
You can't. You're frozen for me.
Again?
Yeah, you can share your screen.
You got to
too, right?
start posing like an Italian or a mime.
Okay, hold on a sec. How's that now? So Dr. John Willard is a chemist, and he made a chemical way to structure water by mixing what is it? Castor oil, metasilicate, sodium bicarbonate. It's different materials and chemical compositions that will retain the molecular structure of water in a certain formation. And when you drink it like that, it's healthy. So you pour it on plants, they grow faster.
Replaces water? Like you could live off of it?
Yeah, it's an alkaline-based concentrate, and you put it in some distilled water, and then you dilute that, you shake it up, you drink it. It's really good. That's what
Should
I've been
give that to
drinking
the
for 15 years.
breatharians.
It turns your water almost like a
No.
light iced tea color. You're like, well, that's not clear. Most people don't like that because they like clear water. You can get a clear version of it, but I like the darker concentrate. And yeah, so it's I've been using it for 15 years. Both of my dogs lived to be 18 years old. I only gave them this type of water their whole life. They were Jack Russell Terriers. Their life expectancy was 12 to 15 years. They're very healthy. Their breath never smelled.
So wait a minute. You buy this water or you like create it from already existing water? What's happening?
I buy an alkaline concentrate, and then I pour a little cap full of that into a gallon of distilled water. And then I drink the distilled.
Shake it.
Yeah, first I filter my water.
I thought you were like creating water from like
no
powder.
Well, no,
like
powdered water.
Crazy.
What?
I don't know what you're doing with
water?
your nanotechnologies and your gravity. There's not propulsion, gravity machines. I want a flying carpet so bad. That's my dream. And so
I have a boathouse I can
not even for me.
Idaho.
That's right.
But there's like I want flying carpets and nanobubble stuff. So
there's like all these benefits and fun things so there's low hanging fruit you can talk about that can actually benefit things like right now. And then there's like the more controversial claims that require more extraordinary evidence.
Ooh. Like what about powering a car with nanogas bubbles? Like could that be like more condensed or not?
Yes. Some people have hydrogen fuel cells in their car, which you make electrolysis with the water, and then it separates the hydrogen gas. You capture that hydrogen gas and then feed that directly into the cylinder of the car, which then makes the gas burn more efficiently. So you can go longer on the same tank of gas. So this Japanese gentleman, Dr. Sosei, Sosei, he developed
first name Kaiser.
Yeah, no, not. So they say.
Julia,
I love that.
He developed something called Sosei fuel water,
so they say.
SFW, And I have a couple. I have a video
So
uploaded on this.
so say fuel water. Is what that's called?
SFW, so say fuel water.
SFW.
Yeah.
That's great.
Right.
Sorry.
And so what it is
This
it's volatile hydrogen gases as a dissolved gas in water, and there's so many nanobubbles that you can use the water as a fuel additive. So you can mix that directly in with oil into the engine, and it won't hurt the engine. Normally, if you pour water into your tank, it's not going to work out for you.
So wait, so
right?
it's nano. It's a water bubbles or it's gas bubbles?
It's gas. It's nano. Safe food water. Yeah. It's
Gas in the
nano
water,
hydrogen that you can add in a certain percentage.
What happens if you drink it?
Then it's you can drink the water as well.
And put it in your car?
Yeah.
What?
Didn't you watch the Shaggy Dog? You know, with like the Disney and the water car. It's like literally that's the car. You know, it runs off that.
I didn't know they had the nanotech back then. Jeez.
So, but do you have to use like heavy electricity and pressure? You said you have to use pressure. Like, what's the?
So that's the you make the
process?
water, and then you have this water. You can have it just in a tank, and then that can be distributed as a fuel additive to mix with the fuel.
So
which
it'll
then goes
stay
directly.
Carbonated, like, or how
not carbonated, but it will stay hydrogenized or whatever. Hydrogenated.
There's a lot of practical purposes. There's a lot.
It'll stay relatively for a period of time. Like you can kind of
because the nanobubbles are so small, they remain in the water. They don't rise to the surface. Okay, here's the.
You can clean clothes with it. Remember, laundry.
Yes.
Well, at this point, I think we're going to use it for military purposes. But yeah,
no, seriously, that's another one. That's like a different. That's a different tier. There's tiers here.
Our military
at home. There's 3 levels, 4. Anyway.
There's a catch with the nanobubbles. It takes a certain amount of energy to compress the gases to that small state, and then once they're there, they will remain there. But if you impact the water and you shake the water, you jostle it, you put more energy into the water than it took to make the nanobubbles, then the nanobubbles will rise to the surface and they'll be lost.
What if you charge it with electricity? Do they blow up? What happens then? Nothing.
The bubbles will flow according to the electric current because the bubbles themselves are ionized gases. They have a small.
So now you can make a cool at-home art thing that people could have displayed with lights through it. That you have this current that makes a permanent heart shape with these bubbles.
No, it's not someone.
They're too small. They're too small.
They're not. They're not vacuums. They're compressed gases. So there's 230, 250 psi in a nanobubble. So it's compressed gases in there.
But you can control the flow. Then no.
Yeah, the Bernoulli principle and fluid mechanics and just standard.
So if there's enough of them, it would create a crazy current too.
Well, if you had electrons, if you had capacitor plates, it would generate some flow of the bubbles in there. Yeah.
Then you can make perpetual motors using water and nano gas.
Oh, no perpetual. No.
Not perpetual, but continuous, like electro.
You can do continuous for a long time. Just say a long time.
A long time, sorry.
There you
go. For a long time motors that have or whatever it is with nano gas in the water, making it if you can control it, like with liquid.
Well, you'd still need outside energy in order to facilitate that. Yeah.
But like the old school mercury lakes and whatnot, they seem like they could have been easier to, if you had magnetic control over that or something. No, I don't know.
What? Oh, like the
Ferris
government TR-3B, the triangular craft that's said to operate like a UFO. It's like a hollow donut, and they have a mercury-like ferrofluid in the donut with coils around that, and they pulse the coils, which then makes the ferrofluid.
It makes sense.
That makes sense. Then you get a superconductive field from that, and then they can generate emissions of gravity. But they interpret that as space-time curvature.
Generating emissions of gravity. That would sound. I like that.
I don't like the whole space-time thing though.
But like you say that, the way you say that, it already changes the way gravity is. People are like, what?
It's just a different way of looking at the same thing.
Gravity?
Britne, did you have any other questions? Like, I know.
There was a couple
Whew.
questions from our super chats. I don't know if we covered.
All right.
Did you
What do we
cover?
got?
Did you cover Travis McClung's question?
What is it?
Can microtubules send and store information?
Microtubules. I'm not sure.
Nanotubules or micro or what nano?
I think this book by Gerald Pollack might be able to help answer that. Microtubules, I'm not sure. I know that what is it, C60 or the fullerenes is healthy, and those are like little nanotubules. So I assume that it would be beneficial. But
nanospheroids, yeah. I don't know. I don't know. Yeah, Travis, if you had like a direction you were going with that question, just ask a bit more about what
and
you
email
want to
me
know.
too. Like email
When
me.
did he ask it? Was this a while ago? Because are these older or fresh? Because he was mentioned nanotubes.
2213. Yeah, it was 10 minutes ago.
Oh no, that was earlier.
Don't need super chat. Just email you, boy.
Yeah, but no, it's interesting to wonder because I guess microtubules are important to eukaryotic cells. So I think he's wondering maybe about like the chemical biology or something. But I don't know exactly what reference your question is for. Still, tubules are cool. I mean, obviously, nanotubules are used for capacitors.
But in regards to information, I'm not sure.
Yeah, I would say yes. I would say the obvious answer is yes, they can be if you wanted to.
I'll say I don't know.
Yeah, if you wanted
liquid
to use
mercury was found under Teotihuacan
and in China.
Theoretically, though, if someone asks you anymore if you can, if someone asks you if you can do something, like the answer is yes. It's just expensive, you know. Like if I wanted to send data through microtubules of polymer, I'm pretty sure I could. So I don't see why I couldn't. So you know what I mean?
Yeah,
that's really the right answer. It can be done.
One thing I wanted to mention about that mercury, mercury when it evaporates in a enclosed chamber, the more it evaporates, the more of a vacuum will be in the chamber. So if you have a bunch of mercury in an ancient tomb with artifacts in it, the mercury will evaporate and over time and produce less and less pressure in the chamber, preserving the artifacts. And if you break that seal of the chamber, you'll get poisonous gases that could come out, and you'll die from those gases, and people might call that a curse. So, like, there's reasons why the ancient people had mercury in their tombs.
You think it was like a
booby
defense?
trap? That's more of a booby trap.
Well, I found it interesting of what Samuel Cohen said. He said red mercury is manufactured by mixing special nuclear materials in very small amounts into the ordinary compound and then inserting the mixture into a nuclear reactor or bombarding it with a particle accelerator beam.
The what?
He said, like, so that's how you make red mercury. And I don't know, with these pools of mercury beneath, like in Teotihuacan, you think it was a defense? Like, you think it was used as a defense system?
It could be, but I think it was mainly used to preserve all of the artifacts and the stuff in there. But if you were to break in there, you would be screwed up from all of the vapors. But I think it was mainly used for preservation over long periods of time. And as a defense too, because if you it will protect itself. Wait a second. I want to see this question in here from Mikhail Lobin. Have I ever come across anything of air being recycled without an external source? No. A system cannot do work on itself. So there's always going to need to be an external source of some kind, even though it can be from an outside system, and then it can facilitate, as a cycle, but not that it can, not without an external source. But you can cycle and recycle and clean the air with these technologies and purify it and clean it for sure, but not without an external source. No, you need an external source always.
Interesting.
Yes.
Yeah. Wondering about water. I mean, because of that, the idea of the two environments, like an external source, reality in general. So, what do you think that external source is
for what?
For our reality, for Earth,
the sun. We're being
Just
powered
the
by
sun.
mainly of the sun. That's our main source of energy, and the sun is a self-contained entity it is probably it's connected to other cosmic processes in
Yeah.
the galaxy and the galaxy cluster and all of that, and Birkeland currents feeding in, but it's mainly a self-contained entity of liquid metallic hydrogen that is dissipating so slowly but with so much energy. It's there's no way that we can deplete that. There's enough energy for generations and more. I mean, come on, it's the sun.
Yeah, but you're still saying like the sun is not a contained system
Yes.
purely because it has to be
Well, it has
affected
to.
by
Yes.
what's creating the sun. Is it a Dyson sphere created by the Nephilim? Tell me more. What is the sun?
Okay. Well, there are hydronium ions. There's when you have a tiny particle in space, it can facilitate electron capture. And so that will start the process of agglomeration, which then can grab
Okay.
another particle and then more electron capture, and then you have electron capture. But then,
Yeah.
and
Electron
then
crystallization. Yeah.
and then it will grow and it will grow over the course of time. It's just a slow
So
process.
you don't think so you think it's grown, not like shattered, essentially. Like it's
Correct. And then you have processes like
sure.
Bennett
That makes
pinch
sense.
and Z pinch also, which can facilitate some of those ions and compressions, which can then have large clusters of that and then start the process off on a larger scale.
That's interesting. Crystalline, I mean, because that's essentially the crystalline theory, right? Like the crystalline metals. So then they're growing and then they would collect. I guess there's a lot of truth to that. It's an interesting idea that the sun could collect.
But that's in space. But then within the Earth, like you have very high pressures.
Yeah.
And water, it boils with less pressure. But if water is in the Earth with massive pressure, it can't boil.
Right.
So it's still liquid.
Similarly,
at super high temperatures. It's still liquid, absorbing like a sponge, leaching all of those elements. Like
right. So you're saying though you don't think that that's making nanobubbles at the core though?
No, there's too much. No, there's too much pressure. There's not going to be there's no Venturi effect of capturing bubbles and entraining air with that. You're ejecting.
It's full pressure.
It's so much pressure. But when you have water at those depths absorbing all of this minerals and stuff, you'll have a fracture like an earthquake, which will release that pressure and flash crystallize those elements equal to the energy that is being dissipated with the pressure levels. Like an electron dropping shells and it releases a photon as an equal and opposite reaction. You have all of this energy pent up, and then when it is released in the form of steam, you have all these elements in that which then flash crystallize equal to the energy of the pressure being dissipated.
Question.
Interesting.
So like gold and all that stuff is formed instantly through flash
electron dropping shells.
Yeah.
What do you mean by that?
Yeah, electron dropping shells. That is in regards to the mainstream atomic theory, so that I could communicate with people so that they can have analogies to absorptions and emissions. Electrons are not ball particles that have shells. So good, somebody caught me on that so that I can elaborate on that. Good. Because I normally I try to communicate to layman's, but if somebody catches me on something, then I'll elaborate. So I subscribe to the structured atom model, which does not have ball particle electrons. It just has a spherical energy of electrons in and around the atom and in the electron between the protons. And there is no neutron in that model. It's a collection of protons and electrons that cancel each other out.
I want to see a picture of that. Sorry. I should not muted them.
Wait a minute.
All right. And
yes. So what else we got? We got the flash crystallization. Yeah. So in regards to all the elements, gold and heavy elements can be formed in a flat. They don't just come from supernova in space from the Big Bang and all this nonsense. You have these metals and materials that can be formed within the Earth during flash crystallizations from the fourth phase of water. Right. So like.
And volcanoes can create lots of instant vitrification and stuff, which is like crystallization, and depending on the elements. Sorry.
Yeah. So there's a lot more than what is commonly taught. So the sun doesn't just produce fusion in its core. They say there's no condensed matter and there's no heavy elements in the sun at all, but yet in the atmosphere around the sun, you have the magnetic fields trapping all this heat at what's called the Alfvén point, like the Nobel laureate Hannes Alfvén, and you have the transmutation of elements into heavier elements, producing like calcium and other heavier elements, because everything is fused together in the atmosphere around the sun, not necessarily in the core. So there's a lot of controversial claims.
Yeah, is that your response to the idea that the core is chaotic, or what? So you're saying the core is not chaotic? Like, you want to respond more directly to the idea of the core being chaotic or not?
I don't think it would be, because there would be too much pressure to have chaos. Everything would be extreme order from the pressure and van der Waals forces, and things would be evenly separated, forming a lattice and a grid. And then all of that
there's
energy
only
would
so
be-
many ways.
Remind me, what are
Van
van der Waals forces again? Could you remind me?
Van der Waal forces are like when magnets are forced together, even though they want to repel, but on an atomic scale. So you have a high state of pressure, and you have the atoms that are wanting to be all randomized, but those magnetic forces that want to repel from all sides are keeping them in an even grid. So an even star shape and an even cube shape. So it's like even geometries in a grid.
And can you manipulate that with sound then and create like a force field or something? Or like how does that work?
Not with sound, but you can with electric currents and electric fields and a high voltage through high energy.
Interesting. Okay. Cool beans.
But you can do that with particles and stuff with sand and stuff, with sound, and you can do that.
Yeah, there's a guy, plasma. He does like, I don't know if you know David Schweimeyer. He has like these liquid plasma bubbles and frequency vibrate, like it's the
David. He's one of my friends on.
David.
He does cymatics with bubbles.
Yeah, I know. I always try. I really wanted to get him on the Real Science Show. Just
you better.
He was maybe going to come on, and then it was like going to be like a month, and then whatever. I don't never know what time the show is going to be on, so I couldn't really tell him.
Let's set it up. We'll set it up.
And he tells you how to build the machines. When I was trying to start new schools, I was like, I got to get these devices. I got to get those for the music class and the science class. He's on my list of teachers for sure.
Somebody mentioned the Sapphire Sun, and the Sapphire project is to try to duplicate the model of the sun. They have this spherical tungsten electrode in this giant vacuum chamber, and they have high voltage electricity. No Photoshop needed, no CGI. It produces like the sun, the energy and heat equal to the sun from this electrode, and around that surface of the electrode can transmute elements just like the surface of the sun, and they take that as being validation for their theory.
Crystal makes the most sense. I mean, the idea that things are growing on top of lattices, like latticed reality. So the idea that the sun at like that density would be crystalline and lattice
at the core. At the core. But then you have liquid.
Oh, I missed that. The sun is the crystal.
The center at the core is like crystalline.
And then this liquidy thing around it.
It's like graphene.
It's also for like.
Is it crystal around a liquid?
It's a liquid around a crystal.
I don't know, like how well educated anyone is here, but in the Rainbow Bright movie, the princess has a giant crystal world that everything shines through, and it is the sun. It's a sparkle. All the color and all of the rainbows come from this one thing. So
brilliant lady.
I feel like the crystalline core is an interesting idea instead of the chaos core.
So you also have liquid metallic hydrogen around that core flowing in convection. So metallic hydrogen is superconductive, even though it's at that temperature. It's so hot because it's a liquid metal. Anytime a metal is flowing in motion, it generates an electric current. Magnetic fields are generated with electric currents. So you have this metallic hydrogen flowing in convection, which generates massive solar magnetic fields, the entire magnetic fields of the whole solar system. Now, normally when you heat up iron, you have a magnet and you heat it up past 850 degrees Fahrenheit, it loses its magnetism. So how could the sun be magnetic if it's that hot? because it's metallic hydrogen and it's flowing in convection.
It's electric. Boogie
Exactly.
woogie.
So it's
Can you explain, or do you think magnetism and electricity, how that they're related, or like
yeah,
in
well,
any way?
magnetism is born from electricity. So anytime you have an electric current, you have magnetism. A static electricity does not have a magnetic field to it. But anytime you arc that electricity and turn it into kinetic, then you will have a magnetic field associated with that spark of electricity in that direction. You give electricity direction, you have a magnetic field 90 degrees to that. And John Searl magnetizes his materials with a waveform imprinted into the materials, programmed. So as you rotate these materials, it repeats that waveform like a tuning fork. So the magnetic field guides the electrons and guides the electricity to flow in a wave. If the electricity is flowing in a wave, the magnetic field will wobble. If the magnetic field is flowing in a wave, then the electric field will wobble. So
Whoa.
it's always a reciprocal claim there. So wait a minute, 369. Somebody in the damn you fine. Now I gotta hurt people's feelings because Nikola Tesla never said anything about 369. It's an internet myth. There's no source for that. I've looked through the Colorado Springs notes and everything, and there's no.
Regardless, vortex math is super cool when
Yes,
you
it
know
is.
nothing of it. And I don't care if they found an antique Tesla map or not. When you see it, you're like, dang, if I had that math class, I would have loved like
I know what you're
math
talking
more.
about. I know what you're
Just
talking about.
different ways of multiplying, different ways of seeing numbers.
That wasn't Tesla. That was made by a math teacher named Joey Grether, and he made that for his kids so that his kids would pay attention to math. So he made it look like an old style Nikola Tesla.
The antique map. I'm just saying
Yeah.
the way that the vortex.
Not real. Exactly.
Wait,
I don't
the
care about the
Einstein
realness
thing,
of it.
where
The
did you?
numbers and how they
Yeah.
work in vortex math is
It is.
fascinating.
Vortex math is legitimate. You
It's
can do
great.
base
It
10,
makes
base
it
9.
so much more interesting, just numbers in general. After you see them that way, you're like, well, now I'm
Exactly.
interested. Like, start math that way, or explain who any of these people behind any of these theorems are. Like Pythagoras, who is that? You don't know anything. And then if you learn that stuff,
Honestly, to be
becomes
fair, for a
interesting.
while I was against Pythagoras because I liked beans. I
I'm
liked to
just
eat
saying,
chili.
even
What?
if you're
And
against or for,
What now?
if you know
Pythagoras
there's a
hate.
story behind what you're doing or
I
how
love
it came to be.
I love Pythagoras, but the
That's
fact
right.
that he's against beans is like, you know.
Beans.
Yeah,
The
you know the
musical
deal?
fruit?
When I found out about Pythagoras when I was like, I don't know, 30, I started doing math.
You can't be
for
part of the
fun.
Pythagorean cult if you eat beans. If you partake of beans, I think it also has to do with like voting with beans because the Athenians use black and white beans to vote.
All right.
But in general, they're anti-bean, and like, how can you be anti-bean? I love Euclid, I love Pythagoras, but I love beans.
Yeah, Mr. Bean is not happy.
Don't judge
What's
a
the
person
deal
by their
with beans?
beans. Seriously, don't judge them.
Wait, Jason, what you about the info you said about Einstein taking that info from who?
Oh yeah, Einstein was a incestuous plagiarist. He was a Karl Marx
Yeah, but
worshiper.
he wasn't all good.
And so like Einstein worked at a patent office, and he was known to be incorrigible and steal other people's work, allegedly.
Stop
Okay?
trying to make him sound like a good guy. You know what I mean?
He the famous E equals MC squared equation was published by a man named Paul Gerber 17 years before Einstein ever
Really?
popularized
You're
it.
gonna give Gerber the credit instead of Lemaire? What do you think about that?
Oh
why,
my God.
Why
Yep.
why Gerber instead of Lemaire? Tell me more.
Because he
like
published it. There's evidence of him actually publishing it in his.
Well, Lemaire published like MC squared is equal to E, right? Like, isn't that what he did? Like, so does that not count? I feel like that's
It was
pretty
around.
close.
It was in the late 1800s or the
Okay.
early 1900s. It was before Einstein, but I think Paul Gerber might have the first publication of it.
All right, I'm gonna give it a go. Look at that.
When's
That's pretty
Lemaire?
I just wanted whoever it was, I wanted to give him some clout.
Yeah, give some clout.
I want to know the
But,
name and
Well,
credit.
the idea that a bunch of people were coming up with things at the similar times is fine. I'm just curious though, because let me see. Like Lemaire says it in 1914 or 17.
This guy did it in like 1896,
Paul Gerber.
maybe before that.
Dude, Gerber babies. That's what we're all about. That's what we're all about. Okay.
Different Gerber, right? No, same Gerber.
This
Probably a different
I'm
Gerber.
just kidding.
He
They've
was
got
from the
to
Czech
something.
Republic, I think. And
it's not showing it on Wiki when he said it. So are they gonna wait?
Ooh.
Question: reprints of Einstein 1917, 1902, 1902. Okay, Gerber wins 1902. Very good,
All right, I'm going to spread it. Paul Gerber. I'm going to make a note.
dude.
I wanna
So,
tell everybody.
Baby food. We can do
he
some
came up-
memes.
he came up
Who's
with
the
that
first?
equation under classical physics. No relativity. Relativity wasn't even invented yet. So he solved things like the perihelion of Mercury and all of these complex scenarios that mainstream scientists say that relativity is the only method that can solve these scenarios. It's not. There are other methods that can solve the same predictions and solutions, but with a simpler method. And the whole point of science and the journey of science, a la Occam's razor, is to be able to achieve the same things with a simpler route. So this man in 1991, Dr. Dowdy, expanded upon Paul Gerber's work and Peter Beckman's work and made justification to abandon relativity. And that's what I've been focusing on for many years, is popularizing Dr. Edward Dowdy's work and his extinction shift principle, which yields the same predictions and solutions as relativity, but without needing space-time, no time dilation, no mass increasing with velocity, no light speed limit.
Yields
none
the
of
what
that.
now? What now is the same? What do you like about it?
I
what
like
happened
it
there?
because
Go on.
we could be living like the Jetsons rather than the Flintstones. We could be traveling the stars. If Einstein was never born, we'd be like already colonized Mars.
Did the Jetsons ever travel the stars? The Flintstones actually
They
visited the
planets.
stars more. No, the Jetsons live in an apartment and they get to visit like the moon. I think.
No, he
right?
worked at Spacely Sprockets. He
Yeah,
got
he
to work,
works. He works all the time. His whole
wasn't
life
an
is
Earth.
just working.
wasn't working on Earth.
It was a. You know that the Simpsons. I'm sorry, the Flintstones and the Jetsons are happening at the same time, right? You know that that's actually
Well,
not
in the
past or
same
future?
timeline, but not the
No,
same time.
no.
Jets, he had
literally,
to travel back in
it's-
time. He had
no,
to
no.
travel back in time.
No,
Uh-oh.
did you watch?
Alternative theory.
Did
There
you
go.
watch the Flintstones meet the Jetsons
movie? Of course
Yeah,
not, but
because there's no timeline. They're just going through the clouds. It's literally through the clouds. It's Aldous Huxley's Brave New World. They're living in the Stone Age because the state doesn't care about them. And if you're part of the corporatist future, you're a slave to Spacely's Sprockets or Cogswell's Cogs.
Ooh.
And
They're
you
just
know, you
up
get
in
carpal tunnel.
they're
Yeah,
towers.
I like this
Are
one.
they
All right.
towers?
Yeah.
All right.
Are they floating? Wait, are they towers?
They're
No.
in these
Touche.
buildings that are moving up and above the clouds. They move them out above the clouds all the time.
I'll concede.
They
All
move.
right.
They're on like a
Yeah.
little ladder
Yeah.
thing.
I don't know.
Yeah,
The
you win.
Flintstones are
Like
happy.
the elevator to the space station. I'm just kidding.
I don't know. Just if you read Brave New World, I'd go with the Flintstones. That's all.
I'm with it.
Otherwise, though, I get the point. We should have anti-gravity. We should have free energy. I think we agree on
Anti-gravity?
all of their
You mean
points.
gravity
Not even-
operating
exactly.
machines?
Well,
Exactly.
we agree
I
on
want just a little magic
Gra-
carpet.
we agree on the idea of pursuing gravity apologetics more because I still need to research it. But the things he said are very interesting and very good. So I'll spend a lot more time.
But
looking into it.
gravity. Can you direct it? So like, let's say there's like a train, so front to back, instead of like up and pulling us away, can you use it then to pull? Like, so you have a train on track.
Okay, so
Can
this
you-
is where I think the gravity and the gravitational shadows come into play. Just like Newton's light, the colors of the rainbow is emissive,
Corpuscles.
and the Goethe spectrum is absorptive. I think that there is probably the same applies to gravity. So you have absorptive gravity and you have emissive gravity and you have push gravity and you have pull gravity. But right now we have so much being absorbed and re-emitted and so much gravitational re-emissions and shadows. It's just in interference patterns, it's creating an equilibrium because we're moving through this like soup of gravity and energy at a constant.
But
So
wow.
Yeah.
Okay. You have a train car. You have push gravity on one side and pull gravity on the other side. Then how fat? Like, are you saying that could be like the way that? And
that
you
would
can
be
keep that-
dependent upon the amplitude of it, just like high voltage, but you would turn up the power, and you could turn
And
up
these
the intensity of
gravity
that focused
emission
beam of it.
machines.
So if you can focus light from a light bulb to a spotlight to a collimated laser beam,
It's like light and
why wouldn't you do that
lasers
to
is
gravity?
like gravity with magnets, or like, oh, I have to study
No,
this.
it would
No.
it'd be
It's
something we
hurting
don't
my
know.
brain.
Or it would be like rotating superconductors would be probably one method.
Mhm.
But other than that, it's
Yeah, because then you're
stuff
still
that's
using
beyond this
magnetics
planet.
or electrostatic. Oh, my other question.
Yeah.
So, like the static charge, you shock somebody, you touch them
Yes.
on whatever.
Yeah.
So, is there like ways to harvest that in people? Not that I want to create like a gun that would cause a charge that would stop someone's heart or things like that.
Yeah, no, you
Is
don't want to
that
do
like,
that for sure.
I'm just saying, is that harvestable? Is that harnessable? What I want to know more about static. It won't stop you if you use certain detergents, but no, like, what is it essentially?
Okay, so wait a minute. So what was the question again
Can
about
you
static?
manipulate it? Can you store it? Can you use it? I know kids like rub their feet and like touch you,
Yeah,
and there's a bigger
exactly.
charge. Certain elements
Yeah,
can
that's
really
a
really
capacitor.
jolt you.
Yeah, that's what a
So
capacitor is. A capacitor holds that charge of the static electricity and then gets rid of it all at once. So here's a fun thing you can do. You walk around on your carpet with your socks or your shoes or something, develop that static electricity. If you have a house plant, go next to your house plant and put your hand next to it. The leaf will be attracted to your hand, and you can make the leaf move without touching it. You can move different things from the static electricity.
sweet.
So there's
Huh.
yeah, what was that, Jules?
Oh no, I was going to ask about the magnets you currently work with where
yeah.
you're at.
We are currently in the research and development phase. I am making magnets one by one by hand in this magnetic laboratory in San Diego. And we make the magnets from powder, we press them, and then I machine them down to the milligram and the micron so that each magnet ring weighs the exact same and is the exact same size. And there needs to be at least 96 of them for the first concentric ring, and then 528 of them total. So I got to spend time on it. Takes me a week in order to just work on half of the magnets, on like the outer diameter of the magnets or something, for let's say 24 of them. So after a month of work, I can get maybe 50 of them fully done by myself, and I need 528. Perfect.
You're
And then
looking
you
for
have different models
volunteers
of
to
them.
help in the area? Because
No,
okay,
because that
is it
requires
like
money.
specific?
that needs
Or
money.
like,
Hire people. You have to have
yeah,
they have to have insurance and be coming from people. They have to be from the proper. So that
background
requires funding.
and field, because it's funded research. Yeah, I suppose you're not just
So we
doing your own
would
stuff.
hire an expert in a specific area to expedite that and automate the CNC lathe that we have. Because I work on a hand lathe and a engine lathe, but I don't know how to program the other one. So everything I'm doing now is just by hand, one by one. But we can hire somebody to like
You have one that's
automate that.
programmable that you could program to do half the work.
Yeah,
or
but I don't
what?
know how to use it yet. So I'm
Oh.
lame because I'm the only one in the lab.
What?
I'm
Is
the
there any
only person.
YouTube videos that explain it, like
Yeah, I'm sure
step
there
by
are.
step? I'm
But
just
you have to
kidding.
learn G code and all these different
Ugh.
codes, and so I'm getting there.
I don't
I've
even know.
had to learn everything in the machine shop.
Never.
Yeah.
Sorry, I just got a
know.
bad taste because my computer is locked out of it. I won't go there. I've talked about it before.
Yeah, machining and lathing, it's like meditative. You get to watch the part just being cut right in front of you and stuff. Just don't stick
Jason,
your
you
fingers
spoke
in there.
about
Yeah, no,
we're
I-
talking about structured water,
I
and you
get it.
spoke
Yeah.
of Dan Winters, that he created like a vortexer, but there's also a magnet in it, right?
Yes. Well, just to answer Crypto Alchemy, our lab is in San Diego. But the what was the question again?
Oh,
With the-
the magnet, like
Yeah, the magnet.
the Dan Winters, the vortex, to structure the water.
Yes.
It has the magnet in it.
Dan Winters imploder nozzle from fractalfield.com. Fractalfield.com/imploder magnetic research. I like memorize these URLs. I'm a freak. So he has this 3D
Imploder.
printed plastic nozzle, which is like a vortex mirrored image. So the water flows in it and then
Dude,
back
I'm
on
gonna pull
itself.
this up.
And then-
Everyone
so the-
should have one.
it's-
Yeah.
So the water flows in on itself and back again and churns it, develops bubbles, hydrogen ions, and then that spun water travels through a tube. On the outside of that tube are magnets forced together, even though they want to repel. So the water is exposed to mainly only the south pole of the magnets, or mainly only the north pole of the magnets. So you have a steel block attached to the back of the magnet. The magnetic field will be absorbed into that steel block, and now you'll have the water exposed only to the side of the magnet that's not connected to the steel block. So you can control the magnetism in material so that it exposes the water or material to only one type of pole. And that's what Van Winter does, is he spins the water, which then develops hydrogen ions. The magnetic field aligns it, and then you water plants and drink it before those benefits disappear.
What's the benefit of charging it to one pole or spinning it to one pole or
It
the other?
aligns the ions in the bubbles of that water. And for some reason, when it is more ordered, you get more benefit.
We're back to that order thing again, just like with the gravity or the whatever.
Geometry.
Anti-gravity. What's it called? Propulsion.
Gravity, yeah.
Searl.
Exactly.
Just like the gravity machine. Okay.
Yeah. He called it inverse gravity because he thought it was like flipping gravity. It wasn't anti. He called it inverse.
Oh my goodness. I like that even better. Oh, that's cool.
And John
That's
Searle
at least-
never
that's at
believed
least
in.
fighting against something.
And John Searle never believed in aliens. Like he thought that was like.
Yeah, he always.
It's pretty racist to call them. It's undocumented workers from space.
I don't know. We just call them illegal.
From spaces?
Makes it
Jeez.
easier.
So
It's less
like,
syllables.
Do dolphins count them?
So yeah, they he actually made fun of people who were like channeling aliens and stuff. He was like making fun of them, saying they were all getting anal probes and stuff. It's like John Searle, man. These people with aliens, they probably have anal probes. He's like speaking this British accent. This is old man. It's hilarious, man. He would say he wasn't fond of the whole alien thing. He did not get his dreams from aliens. I think he got it from his own DNA. I believe in reincarnation. I believe he has done this for many lives with this type of information. And for some reason, his trauma in this life brought it out as a catalyst, and he had epiphanies.
Now, who did you think he was reincarnated? It had something to do with the magic squares, right?
I don't know. You can never tell that.
Magic squares.
But I believe that he probably was reincarnated as somebody who worked with low shoes magic squares like 5,000 years ago. This type of information. You can't.
Was he like autistic? Did he have weird?
He doesn't know.
Yes,
what?
he was very eccentric. I wouldn't say autistic, but he was
like not numbers, like
what's
like that kind of.
Yeah, he was a very unique, eccentric.
And he never found his family. He never tracked down his birth.
You have to
parents.
get those documents to Andreas. Those whatever that those square documents. See if he can.
I do want to see that.
Well, I have those. I have.
Yeah, he wants to see him.
Yeah,
I know.
This was a good 101 so far. I'm like absorbing. I'm gonna look at all the stuff.
That's right.
You know, this is good.
Get 102 next.
I like the idea of inverse gravity instead of anti-gravity. I definitely think we need to get you on a conversation with some of our more artistic friends from Boston. We have like the Boston Dynamics people.
Nice.
But also what Mark Sokol and Jeremy Reese, who do
propulsion
Falcon
inverse
research and alternative propulsion
Can't
guys.
do that.
You don't like him? You don't
no, he doesn't like me. He won't have me on. He won't allow me.
Oh, I can. Get you to talk to
okay.
I'm sure.
Well, maybe you can.
We'll
maybe you can talk to him.
I mean, he might argue loudly with his Bostonian accent, but I think the whole point is, I mean, if you're not Ken Wheeler, like, why not?
Yeah, exactly. That's what I said.
That's what I want the bumper sticker.
He said I'm not allowed to be on the show because he just doesn't know anymore.
I like Ken.
If I wanted to be on his show,
you might
I have
be
to
Ken Wheeler adjacent. Yeah, you have to just be like, I'm not Ken Wheeler adjacent.
Dude,
I've known him for 15 years. He knows me we've known each other for 15 years, and then all of a sudden he's hating on me now. Like
it'll work out.
I'm just trying to be put in the hot seat and ask tough questions. That's all.
Yeah. Well, he'll argue. Arguments are fun. So that'll be good.
Yeah, exactly. So I'm just trying to stick to the technology. I'm trying to stick to the physics of it.
Just to let Jason
oh my
know.
gosh, did you change your name?
He'd love to have you back on, Verbelli.
DJ Bernie Sanders. I love that so much.
Right?
Can
Sorry,
you like start to do
honk
clubs with that
everybody.
name? Oh my god.
I gotta
Yes.
I gotta publish some AI music now, right? But
Oh,
whole
that's
whole
so
point of me
funny.
being here is I talked to Jeremy last week, and Mr. Reese would love to have you on, Mr.
I
Verbelli.
bet he would. That's
Yay.
good. Maybe he can listen to my show with
This
with
one
everyone
tonight, so
else.
you can be caught up and you don't have to repeat it
Yeah.
for everybody. Or
Right?
actually,
Gotta get that info back out there and get your channels back.
Yeah, that would be good. They took my Facebook down, both of my YouTubes down, and
See, that's a good sign.
people
you know?
won't
but
allow
you
me
have
to
your
speak.
TikTok. Maybe it's time to promo that and get that going.
Oh, I do. I've got the TikTok.
Yeah,
I've got
yeah.
Steemit,
The shorts on
Instagram,
that.
Twitter. I got them all. But nobody
Right.
knows I exist.
TikTok's done. Well, yeah, we do. My goodness.
getting
Dude, this
there.
was
I'm getting
awesome,
You're
Jason.
the
Thank
water
you
man.
so much.
You're the water
There you go.
guy. You're the
There you
nano.
go.
You're the nano water guy.
Yeah, thanks for
nano
coming.
gas.
This
You're
is
the
a good
nano
one.
gas
We'll
man.
definitely do
Thanks.
some very
Like what?
soon,
I'm the
and-
gas man.
Nano gas. Come
He's
on.
the gas man.
Nano gas man.
Anyway.
No, you're awesome. This is great. Very enlightening. Awesome to be here. Sorry, I ask a lot of questions. I'm sure a lot of the audience is like on your level, but I'm like,
Is like, who is this
"Shoot,
freak? Get this
I'm way down
heretic
here."
out of here.
I remember, when I learned like the difference between diesel and regular like standard engine, I was like, whoa! I wish I would have taken like mechanics classes and small engines and large engines, and I was like 30, so it's like, yeah, motors, engines, magnets,
All
energy.
that.
It's all so interesting. Water, all the things you're doing and talking about, I find
Yes.
fascinating. So
Trying to help
keep
people.
it up, and yeah, we're gonna get your water stuff going too. We're gonna get the
Excellent.
nano bubbles.
Jason, how do people contact you? You want to say how to
Oh,
you wanna
yeah.
tell them?
Oh yeah. You can email me at verbs@comcast.net. The email that's people are trying to ruthlessly hack all the time now.
Oh well, this is maybe
can-
not the best place.
Okay, whatever. I
Dang
want
it.
everybody to know because I got multiple emails. Just contact me
Okay.
there. And then on my
Verbs with a Z?
yeah,
Do you have a YouTube channel?
VERBZ at
We'll link it in this video.
comcast.net.
In the
VERBZ.
description.
And then on I have a Rumble channel. I have my Twitter page, The Real Verbs, VERBZ. Yeah, there's just lots of all the social media stuff. I'm on there as The Real Verbs because I'm the real one. Other people trying to copy me. Got a bunch of imposters.
Oh, this really?
That's right. Yeah.
There's a lot of posers out there. Did you not? Do you have a YouTube channel where you do anything or no? Or videos or not?
I started to just re-upload a couple things on there, but I'm
Okay.
shying away from YouTube.
Not
I'm
yet.
mainly sticking
That's
to Rumble.
good. No, that's fine. That's good. Cool.
Give them any promotion.
What about you,
Yeah.
Brittany? Recent Tartarians?
Yeah, recent Tartarians. You can go there and find some videos. There's a bunch that are going to be released soon. I say that every time. But yeah, I have some time coming up, and I really want to get this Von Reichenbach video out. But also, yeah, now that I'm talking to these new people, and Jason, you can maybe help me understand this book better
That'd be
because it's
wonderful.
right up your alley, too.
Please.
What is it?
It's that vital force with the
Oh,
magnetism, electricity,
yes.
heat, light, crystallization, and chemism, and their relations to the vital force, which is probably gravity, is the vital force that he's talking about. So all these things in relation to what
It's another
your
word for ether.
concepts of gravity is.
Yeah.
I think, right? Vital force would be gravity.
Vital force would be the ether, which what they thought the
Well, I know, but
deformation
this
of
might
it
actually
was
be the gravity, what you're talking about, actually.
It's another interpretation of that.
Yeah.
Yeah, I'll
But
check
with all
into
these
that.
other things.
I need to see that book.
propulsion and sweetness, yeah.
I told
Oh.
Brittany I want to do a deep dive with her like within the year on vitalism.
Yeah. Oh,
Please.
vital force is vital theory. We gotta do volcanoes someday.
Volcanoes and meteors and that connection
have
and
to, it's
volcanoes. Dude, we'll make it like a
I mean, it's-
documentary.
Yeah. It
For
takes,
sure.
you gotta hone me on volcanoes. It's like, you can't. I'll have to condense a couple topics, but yes. Thank you for hosting.
Yeah,
Thank
thanks,
whoever's the
guys.
host.
Thank you for listening to me
Really-
rant and
No,
rave.
no,
I know it's
great.
weird. It's weird
it's
being the
enlightening.
host with you. All right, all
All
right,
this,
guys. I'll
yeah.
see you later. Have a great night.
Thank you. Nice to
Bye,
meet you.
Julia.
Watch the sun come up, beautiful, till it all burns out. Like falling stars, miracles dancing on the ground. And we're right with you to feel it strike deep dive. We're right with you, yeah. And we're right with you to feel it strike deep dive. Suffering grows, yeah. They say that life is beautiful.